Alright guys, we're going to do our last solving equations lesson today. This is solving equations with the variable on each side. And so sometimes these are just also called multi-step equations. So they're not just the one step and the two step that we have been looking at together up until now. These have a little more to them. And so we're going to go into some additional solving equations rules. First thing we need to do when we're solving equations is we want to simplify the left side and the right side. So sometimes we're going to have things going on either side that we actually are going to need to distribute or combine like terms. So we want to take care of that first before we move on to trying to actually get the x by itself. Second step is going to be to gather the variables. So this is what happens when we, or this is how we describe when we have x's, say, on the left side and the right side. We're going to want to get those terms together. I'm going to make a little note here. I like to move the smaller x term, and I'll talk about that as we work through some. Okay. Looks like my Elmo is working a little slow here. I'm not sure why that is, but we'll kind of just work through it. All right, so for example 1, it says solve 5y minus 8 equals 3y plus 12. So the first thing I need to look for, is there anything I need to simplify on the left side? So if I look at just the left side, I have 5y minus 8. There are no parentheses and there are no like terms to combine. So I don't need to simplify anything on the left side. If I take a look at the right side, 3y plus 12, again, nothing that I need to simplify. No distributing, no combining like terms. So I'm just going to go right into the solving. I'm going to start by drawing my line down the middle, my wall. And I want to gather my variables. I want to get my variable terms together. So you'll notice I have 5y on the left side and 3y on the right side. I want to get those together. Okay, so the way I'm going to do that is the same way I move anything in an equation. I do the opposite operation. I have a 5y and a 3y. I want to move the smaller one, so I'm going to subtract 3y from both sides. Okay. Now, to save a little time here, I moved my y term to the left. So what I'm going to do is I'm going to go ahead and also move this term to the right. So this is a minus 8. The way I'm going to get rid of that is by adding 8. So I'm going to do a plus 8 on both sides. Okay. So from here, now I'm going to simplify. 5y minus 3y leaves me with 2y. I'm going to bring that down. These 8s are going to cancel out. These y terms are going to cancel out. And then 12 plus 8 is 20. So I have 2y equals 20. And now this leaves me with a simple one-step equation. 2y equals 20. So to get the y by itself, I'm going to divide both sides by 2. Remember, whatever you do to one side, you have to do to the other. And that's going to give me y equals 10. Okay. Let's look at example 2. Similar setup here. I have negative 11 minus 3y equals 8y plus 1. I want to get my y's together. I'm going to move my smaller y, which is this one, over here. So I'm going to add 3y to both sides. Okay. Since I moved my y term to the right, I'm going to move this to the left. So I'm going to subtract 1 from both sides. And now I'm going to simplify. Negative 11 minus 1 gives me negative 12. Negative 3y plus 3y cancels out. 8y plus 3y is 11y. And 1 minus 1 cancels out. Okay. So now I have negative 12 equals 11y. I want to get y by itself, so I'm going to divide by 11 and divide by 11. This cancels out, and I end up with y equals, now I'm just going to leave this as a fraction because it's not a very pretty one, negative 12/11. Okay. Now, those aren't too bad, but let's look at one that looks a little more intense here. Now we have parentheses. If you look at example 3, it says, solve 4 times the quantity 2a minus 1 equals negative 10 times the quantity a minus 5. So if you'll remember at the very beginning, I told you that we needed to simplify the left and right side. So what that means is we're going to need to distribute to get rid of these parentheses. So I'm going to start by distributing the 4. 4 times 2a is 8a, and 4 times negative 1 is minus 4. So I have 8a minus 4 equals, now I'm going to distribute my negative 10. This is negative 10a. Negative 10 times negative 5 is plus 50. Okay. So I've gotten rid of my parentheses. My left and right side are simplified. Now I need to gather my variables. So I have an 8a and a negative 10a. Negative 10 is less than 8. So I'm going to move this one because I'd like to move my smaller variable. Plus 10a plus 10a. Okay. And since I moved my variable term to the left, I want to move my constant over here to the right. So I'm going to add 4 to each side. And now I'm just going to simplify. 8a plus 10a is 18a. Minus 4 plus 4, those cancel out. Equals negative 10a plus 10a, those cancel out. 50 plus 4 is 54. And then my last step is to get that a by itself. I'm just going to divide both sides by 18. And again, remember, you can use the calculator on this part. 54 divided by 18 is 3, so a equals 3. Okay. Now, these are the kind of equations that you're going to solve most often where you have one solution. Okay, but there are a couple of special cases. There's a couple of other circumstances where you either end up with no solution, there is no number that x could be, or infinitely many, which means x could be anything. Okay, so I want to show you what those would look like as you work through them. So we'll take care of these with example 4 and 5. Example 4. We're going to start off by distributing to get rid of these parentheses. 2 times 3x is 6x. 2 times 2 is 4. Over here, there's nothing to simplify, no parentheses, nothing like that, so I'm just going to bring down what I have. Now I want to gather my variables, but what you'll notice is my variable terms are the same. I have 6x and 6x, so I'm going to subtract 6x from both sides. Okay, but what happens is those are both going to cancel out. 6x minus 6x is 0. 6x minus 6x is 0, so all I have left is 4 equals 4. Well, because this is true, 4 does equal 4. That means this is x is equal to all real numbers. Okay, we could plug anything in for x, and that equation would still be true. Another way you might see this answer written would be the symbol for all real numbers, okay, which is this fancy looking R with that extra line there. And then sometimes you might see infinitely many solutions. Okay. So x is all real numbers in this case because it doesn't matter what we plug in, it's always going to stay an equation. Okay. So again, that's because our x's canceled out and what we were left with was true. Let's take a look at example 5. Okay. I'm going to start off the same way. I'm going to distribute, this time on the right side because I need to simplify the right side to get rid of the parentheses. Okay, 2 times 5 is 10. And then 2 times x is 2x, so that's going to be a plus 2x. On the left, there's nothing to simplify, so I'm just going to bring this down. 2x plus 7 equals 10 plus 2x. So on this one now, my next step is still to gather my variables, but again, what you'll notice is my variable terms are the same. So if I subtract 2x from both sides, those x's cancel. 2x minus 2x is 0, then I just bring down the 7. Over here, 2x minus 2x is 0, cancels out, and I bring down the 10. So now I'm left with 7 equals 10. Well, does that make sense? No, it does not. 7 equals 10 is false. So if your x's all cancel out and all you're left is with an equation that isn't true, 7 does not equal 10, then this means there is no solution. There is nothing we could plug in for x, no real number that we could plug in for x that would make that equation true. Okay, I'm going to stop there on the notes. You will see some practice problems on Google Classroom as well. I recommend you practice those, and then I'll post the answer key to that as well so you can double check your answers, and then go ahead and try that quizzes that will be posted for a grade. Message me if you have any questions. I will talk to you soon.